Okay, so yes, my name is Steve. You can see my forum username as well, which I'm not sure how to pronounce. So I'm going to talk through how I ended up back using a BBC Micro and joined the community here, how that got me involved in BM, features that have been added to BM since the last formal release, some demos of some of those, and then finally a discussion about where it might go in the future. So with that, shall I move on to the first slide? Let's do share screen. Okay, let's put that in there. We don't want it again. Let's move that down there. Okay, so it's a little bit of history there. I was from a generation we didn't have computers in primary school. First got to see any kind of computer, ZX80 in maths class at secondary school. On the basis of that, thought I've got to have something like that. Got a ZX81. It was a good introduction, but it was very slow. Caused me to learn Z80 assembler to try and squeeze a bit more speed out of it. Then thought, got to get something better. The QL adverts seemed quite good, but a friend of mine worked for ICL. Now, whether he knew about some of the problems, because ICL, I think, were involved in the project, I don't know, but he said the thing to get is a BBC Micro. So I got one, and that lasted me from then until the end of school, and really only fell into disuse when I had access to much more powerful computers at work. So that's the machine that I remember as my childhood introduction to computing. So didn't do much at home, didn't even have a PC at home for many years, but then I got involved in Linux, and from the Anglian Linux user group, I got an invite to an event at BBC Wood Lane. So I then met David Allen, who was the producer for the Computers Literacy Project, and there were some demos there, including a working Doomsday project setup. All seemed very interesting. Was interviewed briefly by BBC Radio 4. I thought, yeah, I should dig the BBC Micro out from the loft. Found that. I found this forum, and then learnt that it would be wise to recap the power supply. So, okay, order the power supply kit. Now, what do I do in the meantime? What if there's an emulator? So I started searching, and I came up with, there were actually two that seemed like good candidates. There was BBEM and BM. Now, at that point, JSB may have been around, but if so, I didn't know about it. B2 wasn't in existence, and neither was BJIT. So the choice did seem to come down to these two. So I had a look at both of them, and which one should I back? And BBEM looked interesting. It had originally started as a Linux or Unix application. Then it got ported to Windows, and then it got ported back again. But the back port was way behind. The Windows version had loads more features. By comparison, BM, there'd been a clear attempt to make it a cross-platform application. It used a library called Allegro 4, which is really designed for writing games, but it included all sorts of interesting cross-platform stuff, and therefore it wasn't tied to the Win32 API in the way that BBEM was. It also supported both 8271 and 1770 disk controllers, and had clear separation between the code that emulated the controller and the code that manipulated the file format. So I thought, I quite like the way this is structured. I think this is good. And then, as you see on the screen, the font rendering looks better as well. So I thought, yeah, that's the one I'm going to go for. So no criticism here of BBEM, but BM, as somebody who works primarily on Linux, seemed like the better bet. So I started using it. And then almost immediately, I came up with this problem. I remembered BCPL from back in the day. I thought, well, I'll dig that out and have a play with it. And we've got this. Okay, so I thought, well, does it work on BBEM? And yes, it did. So there's obviously something wrong with the emulation here. So I tried doing some some single stepping and things, and nothing showed up to start with. It was obviously quite deep into the BCPL ROM. The problem was to be found. And in the end, I ended up hacking both BBEM and BM to trace the 6502 instructions to a file. I then found where it went off into the interrupt service routine and cut that out. I did that with a script. I wasn't going to do it manually. And then I simply diffed the two traces to see where they diverged. And I found it was a branch based on the status of the overflow flag. So then with some help from the forum, I fixed the bug in the setting of the overflow, which was in the particularly in the SBC instruction. I learned about the Dorman test suite, so I got it to the point where the 6502 emulation would pass the Dorman test suite, and then thought, great, right, well, now I've done that, where do I send a patch to? And got the response, well, BM's been abandoned, there's nobody maintains it anymore. But then I learned of this fork by somebody called Fresho, is that with, I'm not sure how you pronounce that, with a 0 in the end there, which was obviously at the source code published on GitHub, and there had been some minor changes as well, I think. And that seemed like a good starting point, so I forked it and applied the changes to that and published it on GitHub. Now then there was a little break because my youngest daughter was born, and when I came back, I found that it had been adopted as an official Stardot project. There was an official Stardot repository for it. And after a little bit, it seemed that I was left holding the baby, so to speak, and have been maintaining it since then. So here's just a visual of that overflow bug. You can see that the behavior on the left, which was the correct behavior from BM, looks visually quite different from the behavior on BM, where it was setting the flag in slightly different places. So what's happened since version 2.2? Version 2.2 was the last official release of BM, and it was quite some time ago. So that was based on Allegro 4, and on Linux at least, the GUI was a bit dodgy. The Windows one was much cleaner because it was using the Windows native stuff. So one idea was to have a native GUI on all the platforms it would work on. And we also hoped that by porting it to a slightly more recent version, we would get the scaling of the video output from the BBC to whatever size you want your window or full screen to be done on the GPU rather than soaking up CPU time. So porting it to something more modern seemed like the way forward. So I ported it to Allegro 5, which is the successor to Allegro 4. And then since then, these various other things have happened. We've got Video Emulator, we've got VDFS, which is a filing system. The whole of the hybrid music system is now supported. So that's the 5000, the 3000, 2000, and 4000. We've got quite a wide selection of tube processors, including some new ones and some existing ones that have been bug fixed. BBEM can emulate a BBC-B with the Integra B card. It supports SCSI hard disks as well as the IDE hard disks that it supported previously. There are enhancements to the floppy support, to the debugger. We've got this logical keyboard mode, keyboard and disk LEDs. We've got copy and paste, print to file, and there's a couple of different ways of working with the kind of games menu and SD and MMC card things. So if we go on to, so this is the result of the port to Allegro 5. So this screenshot's taken on Linux. So this is the GNOME version of the file open dialog box. If you ran it on Windows, you'd get the Windows version. And part of this port has also been to try and reduce the amount of OS dependency still further compared to the Allegro 4 version. Allegro 4 had a whole Linux-specific GUI to maintain and a completely separate set of resource files for Windows. This has one GUI file which creates all the menus. So when it's updated for any platform you can get it to run on. It was quite a lot of change to make it port it to Allegro 5, but it's not apart from the menu bar. It's not something that fundamentally changes the emulation. It's just a usability improvement. So VDFS, this is a filing system. Now the filing system API in the B is unusual. Most home computers didn't have anything like that. Even CPM didn't have anything like that. A way of having a completely different filing system that can be just slotted in place of a previous one. So I came across VDFS as a ROM that I think J.D. Harston had written. Well, he done something based on some previous work, I think by Spro. I don't know what Spro's proper name is, but and it uses the ability to be running in an emulated 6502 and then at some point trap to the host, where the host goes off and does something, and then comes back and you carry on running 6502 code as before. Now the BM implementation is slightly different from the way that worked, in that it does a bit more on the host. It traps to the host much earlier than the original implementation. So for example, it will forward service calls to the host, and then there's code in the ROM that can do various things as needed. So it allows you to share a piece of the filing system on the host that's running the emulator. So you can use it to immediately access files that you've just written on the host without having to use tools to insert them into an SSD file or something of the like. It doesn't use any ROM workspace, so if you don't have a disk controller emulated, you can have page back at E00 and yet have access to files quickly, just like you would with a floppy disk. Now, because most machines these days, certainly it's true of Windows and Linux, have a hierarchical filing system, it seemed natural to present this to the BBC Micro as ADFS-like, because ADFS is also hierarchical, although there's a little bit of NFS in the way that it shows some of the permissions. But it can also emulate DFS. Once you've navigated the directory you want to use, you can flip it into a DFS-like mode, where it will show single character directories and otherwise behave more like DFS. We'll come back to this, I think, later on, and this is one of the things I'm going to demo. But for the time being, let's move on to the hybrid music system. So I think this started with Beach. I think Dave, known as Hoglet, spotted an implementation of the Music 5000 in Beach, adapted it to BM. It was then fairly straightforward to essentially be able to run two copies of it and emulate the Music 3000, which is the extended one. DP11 has contributed some optimizations, which I think were aimed at getting the Music 5000 emulated on Raspberry Pi. The 4000 keyboard is there. You can play it. It's rather laggy, so it's not easy to play, but it sort of works. And interestingly, when I went to implement that, I found that BM's 6522 emulation didn't include the shift register. Presumably up until that point, nothing had used it. But it did explain why, if you try to run genuine system disks for the Music 5000 series, the M4 module that drives the keyboard and the user port would lock the machine up, because it was trying to use the shift register that didn't exist. The Music 2000 MIDI interface is emulated. Essentially, that uses the host's MIDI subsystem. So MIDI notes received are presented to Ample as if they were received on the Music 2000 interface, and vice versa. You can send to the Music 2000 and have the host, either play it on a different synth or route it out onto something external. And finally, we can record the output of the Music 5000 direct to an audio file. That was because the audio can get resampled several times on the way to finally hearing from the speakers, and we wanted to be sure that the Music 5000 emulation was generating clean output. So this is what's been going on with tube processors. The SBC I mentioned earlier, that was the bug that I discovered trying to run BCPL. The same bug existed in the Tube 6502 as on the other one, and that there was a decimal mode was behaving a little strangely as well. The internal and external versions of the 6502 now run at the correct speed. The internal one, I believe, is slightly faster, and the Turbo 6502 is implemented. Remember, I think it was it last month or the one before, we had the source code reveal where there was some the source code for some of the Acorn stuff needed this different version of the 6502 coprocessor to compile. Well, now you can do that on BM, and we had a little demo of that at the end. The Z80, that there were some instructions it didn't implement. It now does, and it passes the test that comes with, forgotten the name of it now, but a well-respected Z80 implementation that comes with a test suite. So it now passes for all the documented instructions. The 32016, when I first started using BM, wasn't quite working. I think Hoglet's been mainly responsible for sorting that out. That's now in the various versions on GitHub. We now have another version of the 65816. The first one was the one from John Kortink, the Rico 65 whatever. But there's now another ROM for that, and you can choose that one. It's the 6009, so you can run a Flex on that, the 68000 and the PDP-11. Right, so disks, SCSI, that's been, make no apologies here, I've grabbed that from BBEM, which had a SCSI implementation. It does have one novel feature though, which is if you, well, for IDE implementations, generally speaking, the image file is padded, so every other byte has a byte for the disk image, and the bytes in between are all 0. And that's because IDE interfaces are usually 16 bits wide. Acorn only uses 8 of them, and it's much easier with the hardware interfaces to not to try and squeeze the pairs of 8-bit bytes into a 16-bit word. It just uses the lower half of the word. So software that supports IDE tends to do the same, so that you have compatibility between the hardware IDE interfaces and the image files. Now, but if you want to run an IDE interface on your BBC Micro, you need the patched version of ADFS. The BM SCSI implementation will auto-detect one of these IDE image files and lets you use the SCSI interface, and therefore the normal native ADFS, if that's what you want to do. We now have support for HFE. That's probably the most important new one. That's the new up-and-coming disk format for protected things. I'm not sure if all protected software works with it yet. It was recently contributed, and I'm not sure if it's been extensively tested yet. It supports another format called IMD, which is a higher level self-describing format, and it supports the SDD and DDD are just, they're like SSD files, DSD files, but for double density support for those third-party boards that I've mentioned on the right. The name comes from Tom Seddon and B2. He was using those for his double density disks, so I thought it might as well be compatible. MMB support. You can load an MMB file directly into BM. And doing it that way, it's not emulating an SD card at all. All that happens is that BM itself traps the din and deabout commands. So when you tell it to load a floppy, what it actually does is work out, looks up in the index what offset it needs and simply applies that to all floppy disk access for that drive. So then it uses the native 8271 or 1770 emulation to access those drives. So you can access files on an MMB disk image through ordinary DFS without having to load something like MMFS or one of the other alternatives. So that was great for actually using the MMB files to play games, etc. Recently, though, we've had an initiative to get away from MMB files and simply put the disk images on a FAT32 filing system. So I've now added support for an emulated SD card to BM, so you can run MMFS2 or one of the alternatives, or indeed the original, if you like, and that does, that work is emulating at the SD card level, and the filing system sits on top of that. BM now emulates the other common 1770 boards that were out in the 80s. There've been various improvements to Debugger. The debugger now supports all the tube processors as well as the 6502. So every tube processor can disassemble instructions, single step, and do all of those things. You can now skip subroutine calls, something that should have been there for ages, I guess. Load symbols in from a file, so you can then use symbolic names to set your breakpoints, and the debugger will also show you when you've reached particular symbols to make it easier to cross-reference through an assembler listing if you've got one. The tracer disassembly of what's going on to a file that I found useful back at the beginning with the BCPL debugging exercise is now something the debugger can do on command, which can be useful for finding some obscure bugs that it's very difficult to see what's going on otherwise. There's a feature to regenerate the screen at a time it wouldn't ordinarily happen when single stepping. That was something that a games developer came forward and said that would be really useful. It's not the default, but it's something you can turn on. And then going back to BM 2.2 on Windows, there was a neat little window which used colors to show you what was going on. There was one color showed that memory was being read, one showed that it was being written, and one showed that code from that patch of memory was being executed. So as that happened, the appropriate bit lit up, and then it gradually faded away. So you could see what was going on. So if you thought your program should be running in low RAM and it seemed to spend most of its time executing in the OS or in the paged ROM area, you know that it's gone off into the woods and not doing what it's supposed to be doing. So here's a bunch of other things that are Steve Flintstone, known as Zorn's Lemma, implemented this logical keyboard mode. So the default keyboard mode is one where you the layout of the keys is physically similar to the BBC Micro, but then the keys don't match the keycaps. So if you're somebody who is used to looking at the keys and expecting to get the character underneath it, that can throw you. So you have a choice now. You can either stick with the original, or you can have the keys generate the symbols, same symbols they would do under Windows, Linux, or whatever your running on. Now that obviously has to do some trickery behind the scenes, because some keys are in the different shift state that way around. So it has to pretend that the shift key is pressed in order to work. There are various keys that control the emulator, so things like pause or run full speed and so on. Previously those keys were fixed and then they got in the way of something, so now the keyboard remapping thing lets you remap those as well. They're just things to map like anything else. An idea that certainly I first saw on JSBeeb, which had the LEDs for the various discs and things. Thought that would be nice, but I never got round to it. Again, Steve Flintham came forward and implemented the disc LEDs. So you can choose to have them on screen or not on screen. You can have them partially overlapping what's there, or off in their own separate area, always there or only popping up when they change. You can now copy and paste from web pages and things into the BBC Micro to paste in programs. You can also do the reverse. You can tell BM to capture the printer output and stick it on the clipboard, which you can then use to paste into a forum post that you're making or something of that sort. Print to file works similarly. You specify a file, do Control-B, print something, Control-C to turn off printing, and then go back to the file menu and toggle it off, and that completes the file. Now, there was a bit of a discussion about what could be integrated in order to enable the output to be printed on a real printer. Now, there were plenty of programs that would convert essentially ASCII text or Epson control codes into something, but there were fundamentally different approaches. Some try to emulate an Epson printer to the point of drawing dots that looked like the pins in the real printer. Others simply translated the output into PostScript and tried to use modern high-resolution fonts. And neither of them were particularly, nothing that implemented any of those approaches seemed to want to take characters poked at it one at a time so that it would naturally integrate with the way the BBC Micro works. So none of them were particularly easy to integrate into BM. So we kind of left it there. At the moment you can capture exactly what gets sent to the printer port in a file, and then you can use whatever tool you like to transform that either into a PDF file or send it to the printer of your choice, or whatever. So of the things I've described here, not everything has been done by me. There's plenty of other people who have contributed work to BM. So, obviously, up to version 2.2, it was Sarah Walker. And actually, I think Sarah's done all the hard work here, because it includes getting the timing right for things and, all the trickery to make some of the protected software work and so on. Jolly impressive piece of work there. Hoglet's been a great help, particularly at the start. As you see, 32016 and the Music 5000. Kieran H.J. wrote the Video Mueller implementation. Dominic Beasley contributed debugging symbols and the new 65816 alternate ROM and some fixes along the way. We've already mentioned the DP11 Music 5000 optimization. So there's Ornslammer, otherwise known as Steve Flintham, keyboard LEDs, and a bunch of bug reports, which has actually been extremely useful. It's I try and test things as best I can, but very often it's not until somebody tries to use something in earnest that you discover that it isn't quite as it should be. Ken Lowe, who also implemented the Integra B support on BeebM, contributed Integra B support to BM. AJ Barnes contributed a change to try and make BM run at the correct speed on the Raspberry Pi. Now we'll come back to that, I think, in the future direction. And then finally, we've got the HFE support from James Youngman. So Now I've got one more slide to talk about the future direction, but I think this would be a good time to take a break and go back and demo some of these things. So I'm going to go back to Video Neuler. So let's move this for a moment. Come on. Okay. Okay. Just remember to.
Hello.
No.
Sorry, wrong. My battered fingers there.
Hello.
Hello.
Oh, come on.
Yeah.
Right, okay. Okay, so Video Neuler, this is the SOTB demo, which you can see is in nice pastel colors. Let's do, okay, we need to, okay, so here we have Jetpack refuel for Neuler, and as you can see by multiple colors of purple, this is obviously using the new palette. Now, when you actually get into the game, there doesn't seem to be much evidence of Neuler on here, but I thought I'd keep this demo in for an entirely different reason, because when I get into the game, move here, and I've discovered a few keys. I've got the ones that are remapped, and I discovered that return does fire, but that's about it. Now I've not really played Jetpack much before, so this is a classic example of here we have a game. We've got the blob for the game, which is being patched by this loader, but there's no keyboard map, no other instructions. Now, whether they were ever part of the original disk, I don't know. Possibly they were, possibly they weren't. Or maybe they were printed. But it's just an example of how something can be great for somebody who's played it before and knows what he's doing. But here's a case where it's not. Right now. Let me see if I can find a forum post. So this is going to demonstrate something else. So we have a little basic program here, which does attribute modes. So let's paste that in. So there we go. That's a demo of the paste feature. So I've just copied and pasted that from a web browser. And this is the attribute modes for Video Neuler. Just watching to see when we get back to. I don't know how many of these there are. Mode naught, I think we're back to kind of standard stuff now. So that's Video Neuler. Let's go back to VDFS. So for this demo, I'm going to do to recompile something using the BCPL ROM. So here we have. Let's edit the file I want. So this is a BCPL program. So it currently says example there. So I'm going to make a simple change to that. So this is gedit in GNOME. It's basically a text editor on the host. You can use any number of similar ones. Now we can go to okay, now we can go to that. So run this, which is this is running on the guest to recompile that same file that I've just edited, and then relink it into an executable. The BCP compiler is not very quick, it has to be said, but it's which is why I'm running it on the tube processor, because it's so there we go. It now says examples. So that's demo the voltmeter, because there's so let's now do the DFS versus ADFS mode. So I'm going to turn the tube off and go for the Model B. Okay. So that's a directory in ADFS mode. So you can see that that's got, well, NFS-like file permissions here. We've got read write for owner, which are the ones in capitals, and read for anybody else, which are the ones in lowercase. If we now change to DFS mode, so there's two commands there, because it's saying we want VDFS to pretend to claim DFS, so that when we execute stardisk, it will grab that. And now we look at the same directory, and now it's it's DFS like, and we can change to the R directory and do a starcat again, and you see that they're now the other way around, just like it would be in DFS. And then we can do, we're back to looking like ADFS. Obviously, when in DFS mode, because you can only specify single directories, you can't navigate around the host file system, whereas in ADFS mode here we can do upper directory and then look at files there. So let's look at that DFS test directory. Let's look at it. We'll see what it looks like on the host. So there's the three files that we were looking at earlier. So each file there has one of these sidecar.inf files. The file format of these is exactly as you'd get from the programs that load and unload host files into SSD files. With load and execute addresses. This only goes as far as the file attributes. So we had a discussion on the forum a while back where that you can put a lot more things in if you particularly fancy it. So let's now go for Music 5000. So I'm just having to consult my cheat sheet. Okay. loading ample. Now what I need to do is to share sound, I think. Let's see if I can work out where to. So,
to load.
yes, I'm trying to remember which key I put this on. Wasn't that one? It wasn't that one. That one. Okay, so you get the idea. Then that was running in Music 3000 mode, so it's got the whole thing, the pair of them emulated. I'm not going to try and demonstrate any MIDI stuff. That just seems like it would be a recipe for going wrong. So let's move on to the tube processors. So the 32016, we need to be in ADFS mode for this. And there we go. It loads Panos. We get a Panos prompt. I'm not sure what I'm doing with Panos really, but there we have it. Let's see what else we've. You've already seen the 650 to external. So there we have 6809. This is one that's been there for a while, I guess. But you can still run gem on this. Already got caught out with the two mouse pointers. Okay, what tube? PDP-11 is new, so I think this is JG Harston's tube ROM, and it will run BASIC if you have the PDP version of BASIC installed. So, well, let's go back to this machine on its own. So in ADFS mode, we've got this disk here. Now let's look at that disk in a hex editor. So there's not much to see at the beginning, but you can see Hugo, the marker for an ADFS directory there. So all of these these look like straightforward ASCII with no, there's nothing in the middle. If we do this appears to be exactly the same. That's still working correctly. But if I show that disk in the hex editor instead, let's move forward to. This almost looks like looking at Unicode stuff, doesn't it? But they have everything is clearly spaced out because you've got columns of zeros between all the bytes that are actually used. So that's the kind of image file you'd get if you had IDE hardware and then imported the image file onto your PC. So that's running in straightforward ADFS that comes as part of the 1 megabit ROM on a master. Right. Okay. So HFE support. Let's see what disks we've got loaded. I got the right thing already loaded. Doesn't look like I have. Okay. Electronic colouring book. That would be good. Make sure we've not got the MMB file loaded. That's interesting. See if it works any better on a Model B. Okay, so this is an HFE disk from one of Chris's Scary Beasts archive that he put up a little while ago. So you can see that's loading fine. Not sure how to drive this program, so I won't demo it anymore. There was one I tried from the archive that didn't work. There may be a little bit more to do on this, but this is a very promising start. So now let's do the MMB games menu. So we can load an MMB file. There we go, a games archive. If we now do so, there you have this classic menu. So I check computer sound. Oops. I think I've inadvertently stopped sharing here, haven't I? Let's give it another go. Okay, so as you heard it from the disk drive noises, it was using the normal floppy path, but it's accessing an MMB file rather than an individual SSD file. So you can load up one of these and flick around the menu and play games to your heart's content. Next thing I can demo is the debugger. Let's quit for a moment. So we start that with the debugger. This is this little memory view I mentioned. It's black at the moment because nothing is happening. So we're going to load a symbols file. Now, one of the new features of the debugger is that it can execute commands from a file, just like star.exec in the BBC operating system. So the way symbols are implemented is there's a command called symbol, which assigns a symbol, and you can specify a group of these in the almost got that right. Okay, so that's loaded. These set of symbols come from one of these basic ROM disassembled and explained books. So I'm going to set a breakpoint on the routine to generate pi, like so, and then continue. And now we're going to try printing pi and see what happens. Okay, so it's working with the breakpoint. And it shows you that this JSR call is to another subroutine. So while I'm here, we can demonstrate the skip over thing. So that JSR, if we don't want to go into that subroutine, N to execute it in one step, and we're back to the next address, having done everything in that subroutine. The way that works is it remembers the address immediately after the instruction you're looking at, and essentially does an internal breakpoint to that address. So if the it's not counting JSR and return instructions, because that can be fooled by tail calls. So I said we can debug tube processors. So I've got that command line option wrong. Let's no, perhaps I haven't. Let's go back to the first one. I think the problem is I haven't got a tube selected. So let's pick one. This is a bit clunky, isn't it? Let's try again. Here we go. So there we go. We're now tracing ARM instructions instead of 6502. And I'm not going to go through them all, but you'll have to take my word for it that the all of the other tube processors are supported. Okay, so let's debugger. See what else we've got. Right, okay, you've seen pasting in from a web page. Logical keyboard mode. So at the moment, if you so we've got turn on logical keyboard mode. Unfortunately, you probably can't see what I'm typing, but I've now got the @ symbol on 2 on my keyboard, which certainly isn't where it is when on the BBC Micro, and the quote character on shifted comma. So that works nicely. So the remap keyboard. Here we've got the usual thing where you can click on any of these, and then you can type the character you want to remapped. But you can also click on these green things, which are functions within the emulator, and it will allow you to do exactly the same thing. So if I clicked full screen and then hit Q, now Q will be full screen, like so. See what else. So keyboard LEDs we mentioned before. So strangely enough, they're under video. So I've got overlapped and when changed at the moment, but you can see there's other options here. So if I do, oh, now I've got caught out because I've got logical keyboard mode and I've forgotten. You see that briefly appeared to show the cassette motor had changed. If we were to put that on all the time, you can see it's appeared there. So we've got caps lock and LEDs for 2 floppy drives, 4 hard disks, and VDFS. So we can turn them off. We can have them separate, in which case it makes the window slightly bigger and tacks them on the bottom. So I think that's the end of everything I've got to demonstrate. Let's go back to the presentation. So the last slide I had was, well, where next? One thing that has occurred to me is that we've not had anything, anything that we call a formal release for some time. Does anybody want a proper release rather than the advice to just grab something recent from GitHub and hope that it works? What do we do with host platforms? I'm keen that it continues to run on both Linux and Windows. Linux because I use it and I know several other people on the forum do. Windows obviously is ubiquitous. But it would be nice for it to be supported on the Mac. I think I mentioned this previously that I don't have a Mac to do the support, although I did get a message saying, why don't I set up a Hackintosh? I've not really looked into that yet. I think my preference would be for somebody who is a native Mac user to partner on getting it supported on the Mac. The Raspberry Pi, yes, it would be nice to have BM working smoothly on the Raspberry Pi. I've not really tried it. I think some people have got it working in the past, but I'm not sure it runs particularly well. And I'm also aware that there's a project that's kind of forked from BM that's specifically aimed at the Raspberry Pi. So if the chap who's doing that is here, perhaps we can mention that. Is there anything else that people want to see emulated? More guest hardware, Econet or Teletext or something like that? Are there games that don't run that we should fix, or features for developers, or, well, anything else? So I think that's the end of the presentation. So over to questions.
Well, first of all, on my part, I should say thank you so much for that very clear and thorough presentation on all the updates that yourself and so many other people have contributed with since BM 2.2. That there were so many features, quite honestly, that I wasn't aware of recently that are great additions to the emulator. I'll just try and zip through some of the questions here. The first one in the list that I saw was around mode 7 and the appearance of it in the BM window. As in it doesn't look quite the same as the font that we see obviously on the native machine itself. And I guess the question is around: is there anything that could be done to improve the font on that?
The aspect ratio is slightly off. We know that, but that's because it's trying to fit mode 7 in with the rest of them, the same way that the other modes work. So the other modes all work in 8 pixel units, and therefore mode 7 is being stretched into 16 pixels wide. Really, it should be 12. So is that what was meant, or?
I guess so.
Because I think the character shapes probably are authentic other than that, because it actually works by upsampling the 9x5 or 6x10 once you've included the separation from the adjacent character, which we think are probably from the SAA 5050 originally. I don't know that for sure, but you can put other fonts in if you like. So
Sure.
I've been doing some stuff on
It just looks a bit blocky, but it's normally fairly good looking.
I suspect it is a scaling issue that we were seeing on screen there, as opposed to the font itself, shall we say?
I think the default behavior is that it scales the window to whatever size. So you can drag the corner of your BM window to a long, thin slit and it'll scale it. So I think what you were just seeing in Steve's presentation was the fact that he'd full screened it on a 16:9 display. And so the window looked much more stretched than it would normally be on a
Yes.
B.
Okay, let's experiment with this. So this is as it starts. Now, to me, that looks reasonably clean, but
You're not sharing.
I'm not sharing it, am I? Let me. Right. Okay. So I think before we go on to the other question, I think we've established from that quick demo, if you resize the window to a different aspect ratio than the one that the BBC Micro naturally has, the font does look very strange because it scales to the size of the window
Yes.
it's told it to.
Okay. And another question I saw was around the emulation of Econet. Does BM now implement Econet like BeebM does? And he's thrown in 2 questions for the price of 1 here. And if so, are they compatible? Can a BM emulator window communicate with a BeebM emulator window?
It doesn't emulate Econet, but that was the reason it was on the list. I know that BM does, and I was thinking, well, what are the possibilities here? It might be something that's that's worth doing. It would certainly be nice if it was compatible, but I don't know enough about the way BM does it to, BeebM does it to make a start on that at the moment. But if it's something that's got interest, then obviously it's something we can look at.
Okay, and it not so much a question, but we just to let you know, I've got masses of feedback, many comments. Besides echoing my sentiments of thanks to yourself and others on evolving BM, but there's massive feedback for saying yes, please could we have essentially official releases? I suppose the binaries for the releases on the platforms. I think by the looks of things, a lot of people do find it difficult to compile from source and so on, and they would much like to have a release that they could simply sort of download and run.
Yeah, that makes sense. I mean, interestingly, I didn't talk about compilation. In theory, you should be able to compile BM with either GCC on anything that's Linux or Linux-like, with Mingwu, which is GCC on Windows, or with Visual Studio. Now, I don't have Visual Studio, so occasionally I make a change and it turns out it breaks the compiling on Visual Studio. But we have had a couple of people who've made contributions who've also contributed fixes to get it back to the point where it compiles on Visual Studio. So, my thinking is it should compile on Visual Studio, because that enables people for whom that's their preferred development environment to actively contribute. So yeah, I'll always accept changes to make it compile on Visual Studio. But yeah, I'm quite happy that we produce binaries to just install and run rather than expect everybody to compile it from source.
I mean, just to extend on that, as in that's something that you'd like to do, or is there any a rude question perhaps? Has there been any work on from anyone on BM with regard to making releases, or are they already available and we don't know where they are?
Well, there are periodic builds for Windows that are in the GitHub repository. Let me see if I can find that.
Right.
Oh, I need to share it again, don't I? I keep getting caught out by this. Now I'm struggling to find it. They really have hidden this quite well. There is an area on here somewhere. Releases, is that clickable? Yes. Now these are all marked as pre-releases because they haven't gone through an extensive testing cycle, and certainly we haven't made announcements and said, would the community please do some extra testing on this after I've tested things to my satisfaction. But they're there and you can download them, and then they install on Windows. So the last one was HFE support and the Turbo 6502. So they are there if you want to install and try these things. But what's lacking has been a kind of, let's pause development for a moment, let's test everything we've got and give it a version number and say this is stable and everybody should use it.
So, but all those builds, or those releases rather, have they made it into main branch?
They will all have been. You should be able to tell from GitHub which branch they came from. I suspect many of them are from the master branch at the time, but there will be a few where something was particularly new and experimental, where it might be a development branch.
Okay. All right. I think I'm going to sort of wrap this part of the presentation, the presentation up, and move on to prepping for the next one. So again, what I want to say is, thanks very much for all your hard work, and everyone else who Steve listed in that presentation for updating BM since the older 2.2 release. Thanks very much, and we'll move on to prepping for the next presentation. Thank you so much, Steve.
You're welcome. I enjoy tinkering with things, so
that's more than tinkering. That's great work, Steve. Thank you.
Right.
Cheers.